in this video. Hello everybody, and welcome to the 54th video on the channel. This is another geometry video, and this will be the final regular geometry video before we go to trigonometry. And after the trigonometry series, we're going to have advanced geometry. Now, I wanted to use this proof of Ptolemy's theorem as a chance to show you what advanced geometry is really like and how difficult the proofs can be, so I can prepare you and you'll be better prepared yourself for the advanced geometry videos. So I think that's all I have to say really. Let's get right into it, but please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. So without further ado, let's go right on to the proof. Alright, so today's proof is about Ptolemy's theorem, as you already know, and we're going to start by using the law of cosines. Now, the reason I chose this proof is, number one, it shows like what the style of the proof is going to be for advanced geometry, and number two, it used some of the basic trigonometry concepts I previously covered. So let's just start. Alright, we're going to have triangle ABC, which I'm just going to quickly highlight in red. Now, triangle ABC, we're going to use the law of cosines for that triangle, with the angle be angle ABC. So, AC squared is equal to AB squared plus AC squared minus twice AB, not AC squared over here, BC squared times twice AB times BC times that's already done, times the cosine of angle ABC. Now we're going to do the same law of cosines, except this is going to be for triangle ADC instead of triangle ABC. So what this is going to equal to is we're going to have AC squared is equal to AD squared plus DC squared minus twice AD times DC times the cosine of angle ADC. So what we have here is two equations that equal AC. But before we equate them, what we got to do is we got to establish a relationship between the two cosines. Now this is pretty easy because in a cyclic quadrilateral, opposite angles are supplementary. That means angle ABC plus angle ADC is equal to 180 degrees. That means the cosine of angle ABC is equal to the negative cosine of angle ADC. So that's pretty much how we're going to relate the cosines. And let's equate them and just relate the cosines and make our life a little easier. Alright, so this becomes AB squared plus BC squared minus 2AB times BC times the cosine of angle ABC. And this is equal to AD squared plus DC squared plus 2AD times DC times the cosine of angle ABC. Now we have plus because cosine of ADC is equal to minus cosine of ABC. So when you flip it around, then you have to switch the sign. So now that we've equated the two equations, what we're gonna do is we're gonna solve for cosine of ABC. Now, if we put all the terms with cosine ABC to one side and all the terms that don't have cosine ABC to the other side, and then we just factor and solve, we're going to get the equation for cosine ABC. So, cosine of angle ABC is equal to, we're going to have AB squared plus BC squared minus AD squared minus DC squared, all divided by twice times AB times BC plus AD times DC. So now that we have the equation for cosine of ABC, we can substitute that back into the original first equation with cosine ABC and AB and BC. So what we're going to get is AC squared is equal to AB squared plus BC squared minus twice AB times BC times AB squared plus BC squared minus AD squared minus DC squared, all divided by twice times AB times BC plus AD times DC. Sorry, not BC, DC. So now what we're going to do is, all we have to do is we just have to cancel out the 2's. And now we're going to make everything have a denominator of AB times BC plus AD times DC. So that's going to be pretty simple enough. We just multiply AB squared plus BC squared times AB plus BC. So now that we have this, we can quickly solve. We have AC squared is equal to AB squared plus BC squared times AB times BC plus AD times DC minus, give me a second. Okay, so we have AB squared plus BC squared times AB times BC plus AD times DC minus AB times BC times AB squared plus BC squared minus AD squared minus DC squared on all of that divided by AB times BC plus AD times DC. So now what you're going to quickly notice is that we have an AB squared plus BC squared times AB BC, and then we have a minus AB times BC and an AB squared plus BC squared right next to it. So what happens is when you distribute everything, that both cancels out. So that leaves us with AC squared is equal to AB squared plus BC squared times AD times CD minus AB times BC into AD squared times CD squared. And all of that divided by AB times BC plus AD times DC. So what we have here is we have an equation. It's pretty good, actually. We're on our way to proving the theorem. But what we got to do is now we got to distribute. So AC squared is equal to AB squared plus AB squared times AD times CD plus BC squared times AD times CD minus, give me a second. If you have AD squared minus plus CD squared, you should have plus over here. That's my mistake, because if you just put negative, negative times negative is positive. AD times CD plus AD squared times AB times BC plus CD squared times AB times BC. And all of that divided by AB times BC plus AD times DC. Now what we have to do to this equation is we have to rearrange the term so it becomes way easier to factor. So how are we going to rearrange the terms exactly? Well, that's pretty simple. We're going to put the first term next to the third term, and we're going to put the fourth term next to the second term. It's going to look something like this. AC squared is equal to AB squared times AD times CD plus AD squared times AB times BC plus BC squared times AD times CD plus CD squared times AB times BC. And all of that, again, divided by AB times BC plus AD times DC. Now, if we look at the first and second terms now, if we factor out AB and AD from those, we'll get a pretty good equation. And then if we factor out BC and CD from the last two terms, we're going to get a pretty good equation, and we're going to get a total factorization. So this is how it's going to look. AC squared is equal to AB times AD into AB times CD plus AD times BC. And then for our second two terms, it's also going to be pretty much the same thing. We're going to have plus BC times CD factorization. And this is going to be BC times AD plus BC plus AD times AB times CD. So now, if you look at the top half, you're going to see that it's going to be very, very easily factorizationable. If all we have to do is factor out BC times AD plus AB times CD. So it's going to look like something like this. AC squared is equal to AB times AD plus BC times CD times AB times CD plus AD BC. And all of that divided by AB times BC plus AD times DC. Sorry, not BC, times DC. Now, this is a very good point, and we're just going to drag this onto the next slide. Now, if you do the same thing with BD, which I'm not going to show in this video, this is going to be like your homework, prove that BD squared is equal to the same expression, but it's going to follow the same logic. Pretty much you're just going to do a lot of cosines for the other diagonal and the other two angles, and do a lot of algebraic manipulation. BD squared is going to be equal to AB times BC plus AD times CD times BC times AD plus AB times CD, and all divided by BC times CD plus AB times AD. Now we're very, very close to getting the full theorem. All we have to do is multiply the two equations. So we'll have AC squared times BD squared, and if you look in the numerator of AC squared, there's going to be AB times AD plus BC times CD, which is the same thing as BD squared denominator. So that's going to cancel out. So those two are going to cancel out. And then the AC squared denominator is also going to be in the BD squared numerator. So now that we have those canceled out, what we're going to get is we're going to have AC squared times BD squared is equal to AB times CD plus AD times BC, and that thing is going to be squared whole square. So all we have to do is take the square root of both sides, and we're going to get AC times BD is equal to AB times CD plus AD times BC. And that right there is Ptolemy's theorem, completely proved using algebraic manipulation and the law of cosine. So I really hope you enjoyed this video. This is one of the hardest and longest videos to make, and see you in the next one. Bye-bye.